Hi, I'm Jeff Carpenter, and we're going to talk about virtual nodes, or VNodes. In a perfect world, we would not have to decommission or recommission nodes. But we're not in a perfect world, and adding or removing nodes from a cluster is something that happens. That said, with normal token range assignments, you must ensure that your token assignments are evenly spread. Adding or removing nodes to your cluster can also make the system unbalanced for a time, and it requires nodes with existing data to stream the data to the new nodes. For example, here's an unbalanced cluster. Notice the yellow node owns half of the token range. Here we see smaller circles that represent the partitions. A good partitioner will spread the partition token assignments evenly across the cluster, but we see in this case, the yellow node has double the number of partitions as the other two nodes. Let's say we decide to add a new node to this cluster. Ideally, our new node will split the yellow node's token range assignment in half. As you see in this animation, this new node does just that. Half the partitions in the yellow node now fall into this light blue token range, and thus Apache Cassandra must now move them to the new node. The yellow node streams the pertinent replicas to the new node. Unfortunately, this puts strain on the yellow node. Apache Cassandra's VNode feature helps mitigate this problem by having each physical node act more like several smaller virtual nodes. Let's examine how this works when we add a node to an existing cluster. With VNodes, each node is now responsible for several smaller slices of the ring instead of just one large slice. With a consistent hash, all three nodes have roughly the same amount of data. That's because each node's smaller portions of the ring add up to 1/3 of the ring instead of the half plus 2 1/4 sections that we saw on the previous slide. The token assignments again change, however. Instead of the new node simply taking over one node's entire token range, the new node takes over several smaller ranges from each of the other nodes. Our partition colors for the blue node change to blue themselves. Now, every node has some data that it must stream to the new node. Each node streams its data in parallel with the other nodes. This makes bootstrapping a new node into the cluster take much less time, and it takes the burden of doing this streaming off of any single node. VNodes help keep the cluster balanced as new nodes are introduced to it and old nodes are decommissioned. The default value for the number of VNodes is 128. VNodes are also great as they automate token assignment instead of the administrator having to manually distribute the ranges. You can configure the number of VNodes by changing the num tokens value in the cassandra.yaml file. And as long as this value is greater than 1, you're using VNodes. Now, let's test out your knowledge of VNodes with an exercise.